Section 1.3 is on algebraic expressions. Mathematical phrases and real-world quantities can be represented by algebraic expressions. Here's an example. Write an algebraic expression that models 1 less than the product of 6 and w. So a couple things we need to know is what some of these words mean. So if I'm talking about 1 less than, that means I'm taking 1 away from something. Product refers to multiplication. So I have the product of 6 and w, and I need 1 less than that, so that's going to be a minus 1. So that's how I would write that. Here's another example. You're on a bicycle trip. You traveled 52 miles the first day. Since then, your average rate has been 12 miles per hour. Write an algebraic expression that models the distance you have traveled so far. So I'm going to need to introduce a variable into this problem. So I'm going to call it h because it's going to represent the time. Okay, so I'm going to say let h equal the number of hours since the first day. Anytime you have a word problem and you're introducing a variable, you need to identify it. Write a let statement and tell people what that variable stands for. So it says I traveled 52 miles on the first day. Okay, and then since then, I've been continuing to bike, and my rate has been 12 miles per hour. So the distance I travel is going to be my rate, which is 12 miles per hour, times the time that I travel, which is h hours. So that's an algebraic expression that represents the distance I've traveled so far. To evaluate an expression means to substitute the numbers for the given values of the variables. Then simplify it using order of operations. Here's an example. I need to evaluate c cubed minus d over 8 if c is 1/4 and d is equal to 1. My first step is to substitute in those values. So I'm going to have 1/4 to the third power minus 1 over 8. 1/4 to the third power is basically 1 cubed over 4 cubed, or 1 over 64 minus 1 over 8. And doing that subtraction, I get that that's a negative 7 over 64. Here's another example. Ticket prices for admission to a museum are $8 for adults, $5 for children, and $6 for seniors. The first thing we need to do is write an algebraic expression to model the total number of dollars collected in ticket sales. Okay, so we know what the cost of each ticket is, but we don't know the number of tickets. For that, I'm going to need to assign some variables. So I'm going to say let A equal the number of adult tickets, let C equal the number of child tickets, and let S equal the number of senior tickets. Let me say something about what I just did there. I chose the letters A, C, and S because that's what they stood for. A lot of times people like to use X, Y, and Z. If it actually stands for something, I try to pick a letter that's a little closer to that. The other thing I want to point out is I didn't say let A equal adult, let C equal child, let S equal senior, because there's actually two things that I need to know about adults: the cost of an adult ticket and the number of adult tickets. So when you're defining your variable, make sure you are specific. Okay, so I need an algebraic expression to model the total number of dollars, and that's part A. So I have $8 for an adult ticket times 8 adult tickets gives me the total cost of the adult tickets, plus $5 for a child's ticket times C, the number of child tickets, plus $6 for a senior ticket times the number of senior tickets, which is S. So that's an algebraic expression that represents how much money they're going to collect in ticket sales. Part B says if 20 adult tickets, 16 children tickets, and 10 senior tickets are sold, how much money is collected? So they're basically giving me the values now for A, C, and S. So I have 8 times 20 plus 5 times 16 plus 6 times 10. And now I just need to simplify that. So that's 160 plus 80 plus 60, which gives me a total of $300 in ticket sales. take a look at some vocabulary that you may be familiar with from Algebra 1. A term is a number, a variable, or the product of numbers and variables. A coefficient is the numerical factor of a term. That's the big number in front of a variable. A constant term is a term that has no variables, so that's just a number like 3 or -4. And like terms have exactly the same variables raised to exactly the same powers. Here's an example. In this algebraic expression here, 3x squared plus 5x minus 4 minus 7x. 3x squared, 5x, -4, and -7x are the terms in this expression. The 3 is the coefficient of x squared. -4 is a constant term because it doesn't have a variable. And 5x and -7x are like terms because they both have the same variable x just raised to the first power. So the simplified form of this expression is 3x squared minus 2x minus 4. We've combined the like terms 5x and -7. So my like terms are combined. And if there are any parentheses, if I have to use the distributive property to get rid of parentheses, I would do that and get rid of those. And here's a little summary of some more properties from your textbook. So if A, B, and C represent real numbers, then subtraction is the same thing as adding the opposite. Division can be written as a fraction, or it can be written as a whole number times the reciprocal of the second one. Notice that B cannot equal 0. Distributive property for subtraction. So in other words, since we have a minus in here, we just have a minus in here. When you're multiplying by 0, you get 0. When you multiply by -1, you get the opposite of the number. The opposite of a sum. Notice that if you have this negative out in front of something added in the parentheses, or subtracted for that matter, that negative gets applied to both terms in the parentheses. It's almost as though you're distributing a -1. So that's going to give you -a plus a -b. Same thing here. This is going to give you a -a, and -1 times -b gives you a +b. The opposite of a product, so that negative is applied to either the A or the B, and the opposite of an opposite, it's like doing -1 times -1, it's positive. And let's take a look at one last example here. We need to simplify this expression. The negative, the quantity, x plus 4y plus 5 times the quantity, 3x minus y. First thing I want to do is distribute, and I'm going to think of this as like a -1 that I have to distribute to each one of those. So that's going to give me a -x minus 4y, and then distributing the -5, 15x, 15x minus 5y, and now I have some like terms. Here I have a -x, here I have a positive 15x, that's going to give me 14x, and then here I have a -4y, and here I have a -5y. Combining those gives me a -9y. So that's simplified. I've gotten rid of my parentheses and I've combined like terms. So in this section we took a look at algebraic expressions, how to write algebraic expressions in a couple different forms, how to evaluate an expression by plugging in some numbers, how to do kind of a basic word problem that uses variables and then plugging those in. And then we did a review of some of the vocabulary from Algebra 1 and took a look at some of the properties you should be familiar with.